Hi everyone, and welcome to Chem Talk, where today we'll be going over how to balance chemical equations. So let's talk about it. Balancing a chemical equation is making both sides of the equation have an equal amount of atoms for every element. So let's look at this equation as an example. Nickel plus O2 makes Ni2O3. The first step to balancing is to count the number of atoms for every element on both sides of the equation. We have 1 nickel on the reactant side and 2 on the product side. And we have 2 oxygens on the reactant side and 3 oxygen atoms on the product side. Now, we want to take the least common multiple of the atoms for each element. So if we look at oxygen, the least common multiple of 2 and 3 is 6. So we need to get 6 oxygen atoms on both sides of the equation. We can do this by writing coefficients in front of the elements, which multiply with their subscripts to give us the total number of atoms. Let me show you what I mean. To get 6 oxygen atoms on the reactant side, we write a coefficient of 3, which means that there are 3 O2 molecules, and in each molecule there are 2 atoms. So 3 times 2 equals 6. Ni2O3 will have a coefficient of 2, because 2 times oxygen subscript of 3 equals 6. Now, the coefficient before Ni2O3 doesn't just apply to oxygen. It applies to the nickel atoms too. So now we have 4 nickel atoms on the product side because the coefficient of 2 multiplies by nickel's subscript of 2 to give 2 times 2 equals 4. The nickel on the reactant side also needs 4 atoms now, since the LCM of 1 and 4 is 4. So nickel will just have a coefficient of 4 on the reactant side because its subscript is 1. Let's try another example together. This problem says that aluminum plus sulfur makes Al2S3. First, we'll count the number of aluminum and sulfur atoms on each side of the equation. There's 1 Al atom on the reactant side and 2 on the product side. There's 1 sulfur atom on the reactant side and 3 on the product side. Let's balance aluminum first. The LCM of 1 and 2 is 2. So Al gets a coefficient of 2 on the reactant side. For sulfur, the LCM of 1 and 3 is 3. So sulfur gets a coefficient of 3 on the reactant side. Let's check our work. We have 2 aluminum atoms on the reactant side and 2 on the product side. So aluminum is good. And we have 3 sulfur atoms on the reactant side and 3 on the product side. So yay, we balanced this problem correctly. Now it's time for you to spread your wings and try some problems by yourself. So pause the video and attempt the following practice problems. Alright, so for this first problem, we need to count the number of atoms on both sides of the equation to see if it's balanced properly. We have 6 carbon atoms on the reactant side and 6 carbon atoms on the product side, so carbon is balanced. For hydrogen, there are 12 atoms on the reactant side and 12 atoms on the product side from the H2O. So hydrogen is also balanced. Now let's check if oxygen is balanced. There are 2 atoms on the reactant side, and we have 12 atoms from the CO2 molecule and 6 atoms from the H2O molecule. So we have 18 atoms in total for oxygen on the product side. Clearly, oxygen is not balanced properly, so this reaction also isn't balanced. So how do we get 18 oxygen atoms on the reactant side? Well, oxygen has a subscript of 2, and 18 divided by 2 equals 9, so we can write a coefficient of 9 before the O2. Now everything is properly balanced. We need to balance this equation next. N2 plus H2 makes ammonia. The first thing you should have done was count the number of atoms per element on both sides of the equation. We have 2 nitrogens on the reactant side and 1 on the product side. And we have 2 hydrogens on the reactant side and 3 on the product side. Let's balance hydrogen first. The LCM of 2 and 3 is 6, so we need 6 hydrogen atoms on both sides of the equation. So H2 will have a coefficient of 3 because 3 times its subscript of 2 equals 6. And NH3 will have a coefficient of 2 because 2 times 3 equals 6. The coefficient of 2 before NH3 also applies to nitrogen. So now there are 2 nitrogen atoms on the product side, meaning nitrogen is also balanced because it has 2 atoms on the reactant side as well. So now we've balanced this equation properly. Now let's talk about the applications of balanced equations to chemistry. Say you're conducting an experiment and you're using a chemical equation to guide you. If you haven't balanced the equation, you may not be adding the right ratio of each reactant into the experiment, which may cause an unwanted result. This is also wasteful because you may be using more substance than you need to. So in order to ensure accurate and efficient experiments, make sure your chemical equations are written and balanced properly. Before you go, let's recap. Balancing a chemical equation is ensuring an equal amount of atoms per element on both sides of the equation. We write coefficients to achieve this. And balanced equations are extremely important in chemistry to carry out accurate and efficient experiments. And that is all for today's video. Thank you so much for tuning in, and be sure to visit us at www.chemistrytalk.org to access more amazing lessons on chemistry. Bye!